everything from creating the most beautiful paintings and music to coming up with the most revolutionary scientific ideas can be reduced down to a next token prediction or curve fitting task. Coming up with Einstein's relativity is an inevitable result of optimizing for compression and prediction, as in using the least number of parameters to predict the broadest range of phenomena. And of course, AI is overhyped in the short term, and it is very much underhyped in the long term. Let's first get our definitions straight. Entropy. Amount of disorder is a very lazy and unhelpful definition of entropy. Here's a better one. Why is it that a picture of a face has less entropy than static? Because if I show you half of the picture of a face, you can tell that the hidden side doesn't look like this or this. It looks like this. You see, the space of possibility for the hidden part gets reduced because whatever the hidden part is, it must have certain relationships to the visible half. Relations like symmetries or proportionalities and other features that make a valid face. Now, what about this picture of noise? Let's cover half of it. The next half can be anything. A meme, a face, an equation, or just noise. Well, what kind of noise? Which pixels have what values? It is completely unpredictable. The space of possibilities for the hidden halves pixels remain as big as it was before observing the visible half. It means the visible side didn't help at all with predicting the hidden half. Another physical example of this is ice has less entropy than water because an H2O molecule near an ice crystal gets convinced to fit into the order of the crystal. In other words, behavior of some parts limit the space of possibilities for the other parts and make their behavior more predictable. More predictable means less entropy. Less entropy means more compressibility. More compressible means you can describe the behavior with less parameters. Entropy. Entropy is the number of possible microstates. That's it. The number of possible microstates. This means in any system with many elements, how much does a certain configuration of a subset of elements constrain the configuration of the other elements. Another essential concept is the idea of dimensions and space. Let me confuse you with this question. How many dimensions does an audio file have? 1, 2, 3, 4. What if the audio contained a conversation between two physicists? Remember, compression and prediction. In practice, you need 1,000-dimensional vectors inside an LLM to predict what is the next audio piece going to be. Let's consider the case of images, nature shots or screenshots of text. A very naive approach is to consider each pixel as a dimension. That's naive because at 99.99% of the situations, the behavior of a pixel is dependent on its neighboring pixels, thereby reducing the space of possibilities for the pixel. Less possibilities means less degrees of freedom. Less degrees of freedom means less dimensions. The point is, you can have higher dimensional behavior embedded into lower dimensions, like the audio of physicists' conversations. And also, you can have high-dimensional objects acting in lower dimensional ways, like a person capable of greatness but stuck in a predictive rut. or a 3D ball only going back and forth on a countertop. Another topic is efficiency of systems. The human brain uses about 20 watts. At first sight, that seems like a great feature, and it was at hunter-gatherer times. But in modern days, when you have access to megawatts, it has become the greatest bug because you can't directly utilize more energy. Eating more sugar doesn't lead to more brain tissue. It leads to diabetes. AI systems can use megawatts instead of our 20 watt power budget. Another important concept is that computation is substance independent. Let's take this AND gate as an example. It can be implemented by water bubbles, steel beams, organic tissue, silicon, gravity of stars, nuclear interactions, whatever. It is mathematically proven that a complete Turing machine can simulate the computations of another Turing machine. The magic happens when you realize one of these Turing machines is Einstein's brain and the other one is a piece of silicon in your hands. My greatest realization is that creating masterpieces of art, engineering, mathematics, and discovering the nature of the universe can be reduced down to a next token prediction. What is true understanding? How to measure if a system, AI or organic, understands. You need to turn it from a philosophical discussion to an engineering problem if you want to make any progress towards it. For our purposes, it will be defined as connecting things together. Let me give you an example. Connecting things together. Having different ways of looking at the same thing, having different paths of going into the same place. The place can be metaphorical, a mental space, a geographical space, a genetic space, whatever. William James's definition of intelligence is very appropriate here. Different ways of reaching the same goal. Different ways of reaching the same goal. That is the definition of intelligence. The goal can be in any space, genetic space, linguistic space, financial space, societal space, mathematical space, scientific space, physical space. This is taken from the amazing book, Surely You're Joking, Mr. Feynman. A Greek scholar goes to the examination of a student who's coming to get his degree in Greek, and asks him what were Socrates' ideas on the relationship between truth and beauty. And the student can't answer. Then he asks the student, what did Socrates say to Plato on the third symposium? He tells you everything, word for word, that Socrates said, in beautiful Greek. But what Socrates was talking about in the third symposium was the relationship between truth and beauty. There is no law of physics that says an AI system cannot understand and be creative. If we are building parrots, that's because of our own incompetence. So on to the topic of building the ultimate substance-independent, true learning algorithm. There is a great insight when you study the history of deep learning architectures. There is a trend of reduction in what is called inductive bias. We hard code features and specific ways of processing less and less, and we let the optimizer figure out more and more of the process. And I think the logical conclusion is that there will be architectures that optimize their data flow in addition to their parameters, meaning as a result of gradient descent they will learn to not use the same number of layers on every token. The amount of forward pass compute will be a function of the input's entropy, not its length. two sequences with the same length, one a work of Shakespeare's and another a repeating sequence of zeros. It is rational to think compressing and predicting the latter sequence is much easier and requires less resources. Yet, our current methods do not utilize this length-independent entropy present in everything. There is an opportunity for a 1000x improvement in efficiency and intelligence. Going forward with videos, I hope to develop the tools for building the ultimate machine learning algorithm. An algorithm that, in addition to optimizing parameters, it can also optimize its architecture.